What is up, everyone, and welcome to this week's Moralis Project. And in this week's project, we're going to build a Medium Web3 clone. So you're going to be able to post blogs onto the blockchain in the form of NFTs. How cool does that sound? You're going to learn how to compile, deploy, and verify your smart contracts using Hardhat. You're going to learn how to upload NFT metadata to IPFS. You're also going to learn how to make this clever UI using React. And then, of course, using the ultimate Web3 development workflow, Moralis, you'll be able to integrate everything into one single package you see over here. So let's go ahead and connect our wallet using MetaMask. Connect. And we arrive at this beautiful front page where we have a list of recommended blogs. These are blogs that are already been minted onto this smart contract we've created and are presented on our home page. If we click one of them, it takes us to the blog post where we have the title and the contents of the blog. You can do the same for any other blog post as well. And then the cool thing is you have your own blogs. So these are the blogs posted by your address, so you can follow which blogs you have actually created onto this Medium clone. And then finally, you can publish your own blog as an NFT if you're willing to pay the price of one Matic. So we can go ahead and test this out. Test blog, I really like tacos. And now go ahead and press publish. You'll notice MetaMask pops up. This is our smart contract address and it's asking us to safe mint with a price of one Matic. We confirm. And rather instantly, we have a successful mint. Okay, we can go check our MetaMask. We have just minted safe mint and we've lost one Matic from our account. Now going to check the home page. Look at this, our test blog minted by our address is added to the recommended blogs over here alongside all the other blogs. I really like tacos, and our test blog is over here. You can also see it on your own blogs over here, which doesn't have that fourth blog that was posted onto the smart contract. And to show you that they're actually being minted, let's go to this contract address over here and look at this, a safe mint 1 minute ago from our address. We minted one NFT. We can look at the token tracker, Medium blog. There's 4 NFTs. We just minted token ID 3. And if we go check out OpenSea, the Medium blog collection has 4 items and token 3 over here was just minted and is owned by you. Really hope you're excited for this build, and let's get going.
Hey, I'm Jay, your Moralis instructor from beautiful Finland. I got into crypto in 2020 and I've been building in the space ever since. In my free time, I enjoy running and at the gym, and in the summer, you'll definitely find me at the golf course. Now, let's get stuck in and learn about Web3.
All right, party people, let's get started with today's build by building out the smart contract functionality we need for our Medium clone. All this smart contract essentially has to do is mint the metadata we have for a new blog into an ERC721 token. This should be quite straightforward, so let's get started by opening up an empty folder in your favorite IDE. I use Visual Studio Code, and in the terminal, install Hardhat. Run npm i-d hardhat. All right, and after that's complete, let's initialize a new Hardhat project in which we can write our smart contract, deploy it, and verify it. So just do npx Hardhat. You'll get a few options. You'll just have to press enter 4 times. 1, 2, 3, and 4. Then before we get cracking with the actual smart contract, let's install all the dependencies we'll need throughout the smart contract development process. So first, let's install contracts from OpenZeppelin, so we don't have to reinvent the wheel, and we can actually use a sample ERC721 contract. So run npm I at OpenZeppelin/contracts. Then when deploying our smart contracts, we'll use the .env file. So let's install .env, npm i-d.env. And finally, for purposes of verifying our smart contract, we'll need Hardhat Etherscan from Nomic Labs. So npm i-d at nomiclabs/hardhat-etherscan. Beautiful, and now we have all the dependencies and our project ready, so you can jump into your contracts folder, open the greeter.sol file, and we can start by changing this name into medium.sol. And to kick things off in this medium.sol file, let's just delete everything we have and define the license and version of Solidity that we'll use. So you will use the MIT license and Solidity 0.8.11 and above. Now after this, you remember when we installed our dependencies, we installed contracts from OpenZeppelin. Here we can import these contracts to then be able to use them in our own smart contract we create for our Medium clone. So we'll be using 4 contracts from OpenZeppelin. First, we'll use the standard ERC721 that defines our NFT token. Then we're using the extension ERC721 URI storage, which will allow us to store our metadata, so the title and the text of our blogs. And then we're using the ownable.sol contract, which allows us to make our contracts ownable so we know who owns a contract, essentially the deployer of the contract, and then any rewards of users posting their blogs on our Medium clone, the owner will then receive the corresponding fees. And then we're using the counter.sol contract to keep track of which token ID has been minted. So every time we mint a token, we increment to the next token ID. Now with these contracts imported from OpenZeppelin, we can go ahead and create our Medium NFT smart contract. So how we do this, we create a contract called Medium, and we use the keyword is, ERC721, ERC721 URI storage, and ownable. This essentially means that our Medium clone also inherits all the functionality from these OpenZeppelin contracts. Now, inside these squiggly brackets, we can write our own smart contract. But first, we want to use the counter to be able to keep track of which token ID has already been minted. So using counters for counters.counter gives us access to the counter, and then we can initialize a token ID counter in our smart contract like so. So using counters.counter, we create a private counter to the smart contract called token ID counter. We'll also want to create a variable that stores the fees associated with posting a blog, or in essence, minting a NFT. So we create this uint256, a public variable called fees, so anyone sees the fees associated with posting a blog onto our Medium clone. And next, we'll have to create our constructor where we define the name of our NFT, the symbol of our NFT, and this fees variable. Okay, so going a few lines down and pasting our constructor. So this is the function that is run at deployment of our smart contract. And it takes as a parameter here a string, which is the name of our NFT collection, the symbol of our NFT collection, and this fees variable where we can define how much it actually costs to post a blog as an NFT. Now the cool thing here is, after our constructor, we can define the constructing variables for our ERC721 contract. So we can do ERC721. Its parameters will be the name that we defined in our constructor and the symbol. And then in the squiggly brackets afterwards, let's go ahead and define that the fees are the fees that we set in our constructor, thus fees underscore, and add a semicolon just to make things work nicely. And then we can go ahead and create our first function, and the only function we'll actually really be using, which will be called safe mint. And it takes as a parameter the to address, who the NFT is being minted to, and the URI, where the metadata for this token will be stored in string format. And this is a public payable function because we will need to pay the fee associated with minting this NFT to the owner of the smart contract, i.e. the deployer. So first, let's make sure that there's a require statement in place where we make sure that the message value sent alongside this call of safe mint function is above this fees value. So over here, let's go ahead and write a require statement. We require that the message value associated with calling this function is greater than or equal to the fees of minting an NFT. And if that's so, we can transfer these fees to the owner or deployer of the smart contract, like so. So calling payable owner, and we get this owner variable by inheriting this ownable contract from OpenZeppelin, and then we transfer these fees to the owner of the smart contract. And now for minting the new NFT, mint NFT, let's first go ahead and get our token ID counter. So we get the current token ID, then we can go ahead and increment the token ID counter. So for the next person to mint, they'll mint the next token ID. Now next we can use the safe mint functionality to mint the NFT to the to address with the token ID from our token ID counter. And finally, we can set the token URI of said token ID to the URI supplied in our function call. So these are functions that we're getting from our OpenZeppelin contracts, and then just making it easier for us to mint NFTs without having to reinvent the wheel and write all the contract functionality ourselves. Now finally, if the case is so that the message value sent when calling this function is larger than the fees, the smart contract would actually just hold on to that Matic or whatever currency is being used. So we can write a little function to return the excess fees to the caller of the function. So let's write that over here. Return over supplied fees. Okay, so first we have to check what the balance of our smart contract is. So we get a variable called uint256 contract balance. We're just taking the address of this smart contract and getting its balance. And then we can just check if this balance is over 0, we'll just send all that excess balance to the minter, like so. So if contract balance is over 0, we just send the contract balance to the message sender or the caller of this function, in other words. And that is it. That is your safe mint functionality. And essentially, that is all the functionality you'll need for this build. The one thing is that if we hover over here, we notice that we have to override two functions. We have to override the _burn function and the token URI functions. So we won't get into too much detail on why you have to do this, but you can just simply override them underneath your safe mint function. So it ends over here. Go down here. Let's write override functions and paste them in here. So now we have the _burn function and the token URI function, and our IDE is much more happy. We have overridden all the functions we need, and our smart contract is ready, believe it or not. So we have the safe mint functionality that allows us to keep track of the token ID that is currently set, and anytime a new mint happens, the token ID is incremented, and the minter actually gets the NFT sent to their wallet with the token URI set to the metadata of that blog post. Now save this file, and then we can jump into the scripts folder and press on samplescripts.js. First, we can start by renaming this and rename it to deploy medium.js. So this will be our deployment hardhat.js file. And we can get going here by removing all the comments, because that will make everything look a bit neater for us over here. And everything is essentially set up for us. We just have to change our variable names to be the correct ones referring to our Medium smart contract. So go ahead and press command find. Let's go case sensitive over here and find all the greeters, because that was the sample Hardhat contract. And we'll change these to medium, as that is what we called our contract. Now, same thing for lowercase greeters. We'll change those to lowercase mediums, like so. Now, one last thing, for the deployment, it is going to require as parameters what the constructor takes as parameters. So our name, symbol, and the fees. So let's provide those over here. So first the name, medium blog, for example. Then the symbol, we can just say blog. And then for the fees, we'll make it so that it costs 1 Matic to post your blog onto our Medium clone. So do 1, and because we have to have the correct decimals, which is 18, let's do 1, 2, 3, 4, 5, 6. Copy those 6 zeros and paste those 2 times. So that will be 1 Matic. And that is our deployment script ready. When we come to deploy our contract, we'll use this. But now let's go to the Hardhat config file to make sure that we can interact with our blockchain, which is going to be the Mumbai testnet. And then we have a crypto wallet we want to deploy with, and also have the details for verifying our smart contract on a block explorer. So without further ado, let's bring the required imports to this hardhat.config file. So this is the package that will help us verify our smart contract, and then we'll require .env, where we'll store all our API keys and endpoint address to our Mumbai testnet node. And for our .env, we also have to configure it. So just paste .env.config and brackets. Now for our module exports, quickly we can use the Solidity version 0.8.11 that we defined in our smart contract. And then let's define, although we don't have our env file set up yet, we can still set up our module exports and then just name the same things in our .env file. So here under Solidity, our module exports object has 2 other keys. It has the networks and Etherscan. In networks, we define the network that we're going to use, which is Mumbai. And within Mumbai, you still have to define 2 keys. You have to define the URL to the node endpoint, and then the account's private key that's going to deploy your smart contracts, like so. So in our env file, we'll have a variable called Polygon Mumbai, which will have the node endpoint for the Mumbai testnet. And then we'll have a private key for a crypto wallet that we're going to use to deploy our medium.sol smart contract. Now for Etherscan, we're going to need a Polygon Scan API key to make sure that we can verify a smart contract that we're actually the one who deployed a smart contract to the Polygon testnet. So simply providing an API key in our .env file called API_key will suffice, but we'll have to go get that API key. Now with this set, your hardhat.config file is ready, but we have to make that .env file so we can get these API keys and endpoints to the hardhat.config file. So let's save this file and go ahead and create a new file called .env. And you can go ahead and populate this with all the variables that we defined in our hardhat.config.js file. So Polygon Mumbai, private key, and API key. And now the problem is to go search for what we need in all of these variables. So let's go step by step. Polygon Mumbai will be the endpoint for our Mumbai testnet node.
So we can get that using Moralis. Go ahead and go to your browser and go to moralis.io. So the web page should look something like this. So you can start for free if you don't have an account already, but if you do have one, just log in. After you've logged in, you'll come to your Moralis admin dashboard. It will look something like this, but if you're going through this project sometime after this tutorial has already come out, we might already be moved to the new UI. So don't get worried, all the same stuff will be available, it'll just be in a different layout. But you'll have to go to the speedy nodes on the left sidebar over here and choose Polygon endpoints. Now from here, we have the Mumbai endpoint. We just copy that and then go back into our IDE and we can paste that over here. That's 1 out of 3 done. Now we'll do the private key last because it's just good practices never to show your private key, even if it's a test account to anyone. Just keep those private keys to yourself. But let's look at the API key, which we can get by going to Polygon Scan. So find yourself here on polygonscan.com and sign in. After you sign in, your homepage should look something like this. You can go to API keys and add a new API key, give it a name, medium, and you get your API key. Please be sure to go make your own API key because I will have deleted this API key by the time this video comes out. So go ahead and paste that into your IDE like so. And then finally for the private key, I'll show you how to get one, but I won't paste it in here. Just teach you good practices, even though I'm on a test MetaMask account. So in your browser, open up MetaMask. We'll use account 1 over here. Press these 3 dots over here. Press account details. And then you can press to export your private key. This is your public key, public to everyone, but your private key you should only have for yourself. So you can press this and then you'll get your private key and paste that in to your .env file. So the private key goes in here, and then we can go back to our hardhat.config.js file, open up our terminal, and we should be ready to deploy our smart contract.
Right, so what you'll want to write in your terminal first is going to be npx hardhat clean. Now the next command will be the exact same, but this time compile. So you notice you might get a warning that the version of Solidity might not be fully yet supported, but in our case, this should be fine. And our Solidity files were successfully compiled. Now next is going to be the deployment. We've compiled our smart contract, so now we want to deploy it. You can go ahead and clear your terminal to make you some space and then type in npx hardhat run. And then we want to look into our scripts folder and the deploy medium.js file. So scripts / deploy medium.js, and then the network we want to deploy it to is going to be Mumbai. Now press enter, and Hardhat is hard at work deploying your smart contract onto an actual blockchain. How cool is this? And would you believe that 0xEA5 is your smart contract deployed to the Polygon Mumbai testnet? Now we can also verify this contract straight away. So go ahead and copy this smart contract address, type in npx hardhat verify your smart contract address, and then the network Mumbai once again. All right, we get a good error. We forgot to provide our constructor arguments, which we had 3 of. So let's open deploy over here, where we had medium blog, and 1 matic. So let's do the same command, just at the end, provide all the deployment constructor arguments. So medium blog, and then 1, and then 18 zeros. Let's go ahead and try this one more time. And boom, that might take some while, but at the end successfully verified your contract on Etherscan, but it actually means Polygon Mumbai testnet. So now we've completed, and we can go check out our smart contract at this address in Polygon Mumbai testnet block explorer. Let's go give it a look, shall we? Okay, so here on mumbai.polygonscan.com, we can search for our smart contract address, and look at this. I had a little lunch break, so only 29 minutes ago we actually created this smart contract. But now if we go check out the contract, you see it has the little green tick mark, and we see all our code that we wrote earlier on, and we have all the other files as well that we imported using OpenZeppelin. And all this is readily available here publicly on the blockchain. What's even better, we can read the smart contract, so we can check the balance of our NFTs for any crypto wallet address. We can see the fee, so we see that it is 1 matic to post one of your blogs. And we have all this functionality. We even get the owner, so the owner is our account 1, 0x42, because that was set using OpenZeppelin. And now, if we go to write our contract, we can actually go ahead and mint an NFT in the form of a blog. We only have to have an address where the metadata for our blog is stored, and luckily I've set one up already. So I have this
set up using IPFS and Moralis. You will get to that later on in the video. But I essentially have an image key, which has a small image of Moralis, the description of our blog, Jay's first blog, and then an external URL that takes you to another IPFS URL over here. And it just has the title, Jay's first blog, and then the text of our blog. Hey, I'm Jay, blockchain developer, advocate from Helsinki, Finland, yada, yada, yada. So we have this token URI we can use to actually mint our smart contract. So we copy that. And here where we want to mint, let's first connect to Web3, and let's connect another account so we see the transfer of funds as well to this owner of this smart contract. So let's go to account 2, which has plenty of Matic over here, and connect to Web3 using MetaMask. And look at that, account 2 is connected, 0x5D, and we can go ahead and save mint, paste our token URI, paste our one Matic, and to address will be our message sender. So whoever is interacting, paste that in there, and now write. We don't get any errors. Our estimated gas fee seems a bit slow, so let's just edit that. Let's put a high gas fee, so this would go through quicker, very likely in under 15 seconds. Confirm. Our safe mint is pending, but now it is minted, and we can go read our contract. So let's go ahead and to the bottom, token URI of token ID 0. Our counter always initializes at 0, so this should be the first token we query. And look at that, token ID 0. The metadata is stored at this URI. Now as well, let's go check out our transfer of funds. So now our 20 Matic has gone down to 19 Matic, and account 1 has gone up from 8 Matic to 9 Matic. So the transfer of funds has worked properly as well. How cool is that? Our smart contract is working. Last thing to check is going to OpenSea and seeing if our minted NFT is in our wallet. Okay, and here we are in OpenSea. We're on our account 0x5D, which is account 2 over here. And look at this, we have quite a few from our previous projects, but we have Medium blog token ID 0 over here. We have the image that we've preset in the token metadata, and we see it's Jay's first blog. So how cool is that? Everything's working fine, and now we can move on to creating a beautiful front end for our Medium clone.
All right, so for our front end, we're going to use React, and we've created this starter repository for you, which you can clone from the link in the description below. And the first thing you'll want to do is install all the dependencies by running yarn in the project folder in your terminal. And now with all the dependencies installed, we can take a quick look at the repository. So it's a basic React app. All the files you need are stored in the source folder. Let's look at app.js. We've already defined a basic structure. We have a sidebar and a right bar. And then in the main window, we have 4 different routes. We have a home page. We have a new story page where you can write a new blog post. Then you have a My Blogs post, which will be similar to the homepage, just have a list of your already minted blogs. Then you have a blog page where you can read any uniquely identifiable blog. And we're going to go ahead and start building this app.js file first. But before we do that, head over to the index.js file and be sure to add your app ID and server URL for your Moralis server. So you can do that by going to moralis.io. After you've logged in, you can create a new server, create it on the Polygon one by testnet, and then view details of your server and get your server URL and application ID and paste those over here. Like so, save the page, and then in your terminal, you can just run yarn start and localhost should open up for you. And so it does. Look at this, we have a clear structure for our page. We have our slightly smaller sidebar over here where we'll put our Medium logo and the different pages and a logout button. And we have our main window where we'll have all our main content. And then we have a right bar just for stylistic features for now. But now let's go ahead and start building this out. Rightio, so back here in our repository and in the app.js file, we're first going to make sure that we have authenticated state and non-authenticated state that allow us to log in to our Medium clone using our crypto wallet. And to do this, we can use Moralis. So first, let's import a logo of Medium and then the connect button from Web3 UI kit, like so. Then we'll also need to use Moralis to check whether a user is authenticated, and let's destructure from use Moralis the is authenticated variable. And now with the is authenticated variable, we can create a conditional view of our app.js. So what we have currently, we want to show if the user is authenticated. So if is authenticated, we show what is currently within our app.js file. But otherwise, let's close this bracket and create a new bracket. We want to have our Medium logo and a connect button, which allows us to get to this standard Medium view. So all we do is create a div in here called class name unauth, so the unauthenticated div, and within here we add an image and the connect button, like so. So at the top we imported logo from images/medium.png, so we get that from there, and then connect button is imported from Web3 UI kit, and now we should be nicely set. We just close this with a squiggly bracket, and now we are all set. Save that and go check out our app. It's worked like a charm. We have this nice front page with a big medium logo and our connect wallet button. If we press that, we can connect with MetaMask, choose our account, sign in, and now we get to the front page. And now we can go ahead and create the sidebar where we have links to different routes and then a logout button that would take us back to the unauthenticated state. So let's do that here next. Go back to Visual Studio Code, go to the components folder and the sidebar.js file, which is an empty React functional component with just this one div with a class name cider content. Now let's import first what we'll need. We'll need a link from React Router and then use Moralis again to handle logging out. Then we're going to need a couple of icons for the logo and the different pages. So they will be like so. We're using Material UI, and then we have one image just in the images folder in the repository itself. And then we can go ahead and start off by writing a little function that will handle our logging out. So to kick that off, we'll destructure logout from use Moralis. And after that, we'll write the asynchronous function to log out, which is only a await to log out. So as long as we call this logout function, we will unauthenticate from our dApp and go back to the connect wallet page. Now, that is all the functionality we need in this functional component. Now for a return statement, start filling this div out. So of course, in the top left of the sidebar, we'll have the logo. So we'll put the medium logo we brought in from the images folder. Then let's create a div in which we store the menu items. So the home page, your blogs page, and write a new blog page. So like this, create a div with class name menu. And within here, we can add 3 links. They'll follow this structure. You'll have a link to the home page, and then it'll be a div inside a class name menu items, and then it'll have the icon brought in from Material UI. So we'll do this 3 times. This is for the home page, then we'll have one for your blogs page, and then we'll have a new story page like so. Let's just format this nicely. And now if we go check out our page, save that. That looks excellent so far. We can route to different pages. You see that the URL changes in the address bar over here. And finally, we add a logout button. And because this is set using space between, it should put this home in the middle of the sidebar. So let's add a logout button to the end. All right, so we have our div menu. So underneath this div, we'll create a new div called logout, and on click will handle the logout event, and it'll have the logout icon. Save that, and we should have a completed sidebar. Wow, look at that. It's a simple, sleek design, but we have a logout button. It works as well. Takes us to the front page, and we can connect our wallet again using MetaMask. And we're back at the home page. We can route to different pages. So we're making great progress. Now let's make a stylistic right bar, and then we can go ahead and focus on the main content in this main window. All right, so jump back into Visual Studio Code, go to the rightbar.js file, and you see that we have a trends array here already set, and this is because we're going to focus on this right bar just as a stylistic event. We won't actually integrate it to have any functionality. That's a little project for you if you'd like to take this further. But here, we'll first import our input from Web3 UI Kit, so we can have a nice little search bar in this right bar, and then we can just go ahead and start filling it out. So in this div, right bar content, we can start by adding the input we just imported from Web3 UI Kit. We'll make sure that it has a label search, so it indicates to the user that you can search for different blogs over here. And then after that, we're just going to map through all these trends, and they'll create a nice little illusion of different blogs that you could select to go watch. Let's add another line here and paste it in here. So we have this div called class name trends, and it has a heading called what are we reading today? And all we do is map through the trends array and return a div with the text in each of these objects. So what this looks like in practice, we save this, go check out our app. Won't you look at that? It's beautiful. We have what are we reading today, real performance paradox, the forgotten benefits of low-tech user interfaces, etc., etc. And we have a beautiful search bar as well. As I said, there won't be any functionality in this build, but what you learn coming up here in this tutorial, you can implement in this right bar as well to make this right bar functional as well. But now let's focus on this main page, and starting off with the home page, which will have a recommended set of blogs that you can, when clicked, will take you to the blog post itself, and you can start reading it. All right, so let's go ahead and jump back into Visual Studio Code, and we can go away from the components folder and jump into the pages folder and open up homeauth.js. Let's close some of these windows to make this look better. And now you see it's an empty React functional component once again, and we can start by creating our functionality to fetch our blog post. And because we have one sample blog post already that I also created on the smart contract just a while back, so we have the token URI for that blog, so we can use that as a sample over here. We just need to import one thing, Axios. So import Axios at the top of the script like so, and then let's create a few state variables. So first of all, we'll have an array of blogs, which eventually we will get by using the Web3 API, but for now we'll manually fill it. And then blogs content will use Axios to fetch the token URI and the title and the actual blog post text itself and store that in this blog content array. So let's first of all fill out a hard-coded blogs array, add an array here, and the array will consist of objects with keys external URL and owner underscore of. Now this owner of, we can just set a sample XXX wallet, but the external URL, you can go ahead into the config file and get constants, and then we have a sample URI over here, which is a sample token URI. We can copy that and go ahead and paste it in these quotes. Now after this is set up, we can go ahead and create a function to actually go get the blog content from this URI. So let's create an asynchronous function called fetch blogs content. As you see, it's an asynchronous function. Then, just for future reference, we'll limit the amount of blogs we fetch to 5, the 5 most recent ones, just so we don't have to fetch all the different NFTs that have been created in the future. For now, we just have that one, so we'll only fetch that one. Then we'll create a temporary array called content blog, which will eventually become this state variable blogs content. And now, as long as we have this limified, as long as we have an array of blogs, we can go ahead and map through all the objects in this blogs array and use Axios to fetch the title and the text of each blog post we have. So over here, let's make some space and paste this in here. So as long as we have a blogs array, we can map through it and we destructure the external URL key and the owner of key for each blog object. And then we go ahead and use Axios to go fetch our JSON in this external URL. Let's just go check what the external URL looks like. So if we fetch this, go to our browser. So as you remember, just an object with a title key and a text key. So this is the JSON response we will be getting using Axios. And then all we do is we turn the response's text key to a string, and then we just fetch the title, and then we push the title and the text alongside the owner of an external URL into the content blog temporary array as an object. So you see that if we had more blogs, we'd get all of those. And then we can go ahead and use this array of objects to fill out numerous blog cards on our front page. The final thing we have to do is just make sure that we set this content blog to our blog's content state variable like so. So now we have this fetch blog contents function, which fetches blog data for the different blogs that we have minted. Currently it's just a hard-coded one, but later on we'll use the Web3 API. Don't worry, we'll get to that at the later part of the video. And now we just have to run this fetch blog contents function and create a blog card component that fills the details nicely onto our UI. So what we do, we create a simple use effect that runs on mount. So as long as we have a blogs and we don't have blogs content, we fetch our blogs content. And now for the UI bits, let's first add a header. We can just call this homeauth_header and say recommended blogs. And now the content will just be numerous different blog cards representing different blogs. So all we have is a div called homeauth_blogs, and it maps through our blogs content, gets the title, text, owner of an external URL of each of our blogs, and returns a blog card component, which is past the title, text, owner of an external URL for easier rendering in this blog card component. So let's go ahead and create this blog card component, save this. At the start of our script, import blog card like so. Blog card is imported. And now we can go over into our components folder and open up blogcard.js. At this point, actually, we could go to split screen mode like so. So now we're in the blog card component, and you see that already in the home.auth.js file, we rendered recommended blogs at the start. And now whatever we render in blog card should pop up over here in our recommended blogs. So first of all, what we have to do is import the props like so. So we bring in text, title, owner of, and external URL. Now, in the blog card, we won't want to present the full text, so we want to trim it to say 100 characters. So let's create a constant called length equals 100. Then what we'll do is we'll create a variable called trim string, which will be the 100 character string of our blog text. So we check the length of our text. If it's greater than 100, we create a substring from 0 to 100 characters, but otherwise we just present the whole text. Now we also want to present who the blog was posted by, so we use the owner of variable. And you know what, seems like this split screen mode is a bit too small for now, so let's just open this full screen for now. And you see that the account we set to the owner of, and we slice the first 4 digits and last 4 digits to get a nice compact address to represent who the blog post was posted by. Now you might be wondering why we need the external URL, but let me show you. So in home.js, we pass this external URL. And what we're going to use is this last bit of string because it will be unique for each IPFS file. So we can use that to represent our different blogs. So let's import use navigate from React Router. And then we can create a onClick handler to navigate to the blog page with the external URL's unique string. So we can call navigate from use navigate and then create this click handler which takes the last segment of the external URL. We just split everything behind the last slash. And then we navigate to the blog page with that last segment. So that gives us a way to present a unique blog on the blog page when we come to creating that blog. But now that has everything set up for the functionality of this blog card component, but now we can just render what we want to present in a blog card. So of course, if someone presses the blog, we want them to navigate to the blog that they clicked on. So that's why we add this onClick event to this whole div that we wrap everything around. Then we go ahead and create a left side for our blog, which we will fill with the blogger's details, whoever the blog was posted by. So we can put the account that we calculated over here, and then we can also have a date. We don't have a specific date, but that's a nice functionality for you to add as well. So we just put a hard-coded March 21st. Now, after the blogger, we're going to want a blog title. So we can just use the title that we bring in as props over here and give it a heading 3. And then finally, we want to add a trim string that we calculated. So the trim string will be a paragraph, and we add 3 dots to the end just to indicate that it might be going on. So now that has a setup for the left side of our blog card. Let's see what this looks like. So save, go to split screen mode, and look at that. That's beautiful. Jay's first blog. Hey, I'm Jay, blockchain developer. That's being pulled from our URL using Axios. And our crypto wallet address we just set to XXXX, so that's not presenting anything more significant. And then we have our March 21st date. But now here on the right side, let's add an image. Let's go over here and see where our left side div ends over here, and then add a right side div which has an image inside of it. And for the source of the image, we can just use a hard-coded image. Let's go to your file structure, go into the config constant.js file, and we can find this logo. This is a nice blog post cover image that you can use. Again, this is functionality that you can build into your own project yourself where you're minting your NFT. You can store an image for that blog of your choosing, but that's a project for yourself. We don't want to give you all the goods. We want you to learn as well. So we just provide that source over there, save that, and would you look at that, we get a beautiful logo image over there. So we can open this up full screen. Look at how cool this looks. And of course, if we had more blogs in our blogs array, they would all be presented over here in consecutive order. And eventually we'll use our Web3 API to get all the NFTs which represent blogs in our smart contract to be represented over here. And now if you click this, it takes you to the blog page where we have our unique identifying code for our blog, and we can go ahead and present our blog here. So let's go ahead and jump into creating this blog page. Rightios, back in VS Code, go ahead and open up your file directory, go to blog.js, and we can actually go full screen over here. And it's an empty component. We'll first have to bring on our imports, and this time we'll have to import 3 things. We'll import use params from React Router because we have a parameter in our address, the uniquely identifying string for each blog. So we need to extract that. Then we're going to use Axios again to get the full title and text for our blog. And then we're going to use the URL constant from configs. And let me just show you what it is. So it is this IPFS gateway from Moralis. So we can search for the correct endpoint with Axios. Now, inside our blog component, let's define a few state variables. So we want our title for our blog post, and we want the text for our blog. Then next, we want the URL destructured using use params. So let me show you what this is doing. So if we go back to our app.js file, you notice that our blog path has this URL parameter. So that is what we are getting when we are destructuring URL by use params. And in our blog card, if you remember, here we provide the last segment to be the URL parameter. So that is just what we're getting. So now we just need to make sure that we use this URL for the IPFS gateway using the unique identifying string, which is this lowercase URL, and we should be able to get our title and text. So here we'll go ahead and create this asynchronous fetch blog content function, which just gets from Axios using our endpoint and the uniquely identifying string, our title, and then the blog's content itself, the text. And now as these are set, we can go ahead and render our blog page. But first we have to make sure that we run this function. So let's just run it by using a use effect over here. So we just make sure that we don't have a title or a text, and then we fetch our blog content. And that should give us our title and text, and that is all we need to present on a blog page. So jumping into our div that wraps all our blog. We won't spend too much time doing this, but we have a single blog wrapper, we have the content, and the single blog content will wrap a heading, which has our title in it, and a paragraph, which has our text in it. And we've added some nice styling, so the first letter of our paragraph is nice and big. You'll see that in a bit. So if we save this, go check out our app. Well, would you look at that? A beautiful Jay's first blog, and then we have all the blog content. This is a very short blog post, but you get the point. It's very nice. Let's go to our homepage. You see we have all our blogs. We can click it and it takes us to our blog page. How cool is that? Next thing, just creating our My Blogs page, which will be essentially the same as our homepage. Just eventually we'll use the Web3 API to get the logged in wallets blog post themselves. And then in the last page, we'll allow the user to actually create a blog post themselves. All right, let's get cracking and create this My Blogs page. And luckily now for the UI, it'll be very similar to the homepage, so we can just copy most of the code from there. So let's go to pages, myblogs.js, very empty file. But now go to home.auth.js and let's just start copying some codes from here. Get Axios and blog card, which we'll both use, input them in here. Then from home auth as well, we'll have an array of blogs because we'll use the Web3 API to get this account's blog. So it'll be the same functionality and give us the same object outputs, but just for this specific account. So we'll get these same state variables, paste them in here like so, and then fetching for these blogs, totally same functionality, get the fetch blogs content, and we'll also get the use effect in the same package, paste these in there. And then here is the slightly more interesting part, creating that rendering for our page. Let's save for now. Go ahead and add a header for your page. So my blogs header, your blogs, not Yout blogs. It's going to be your blogs. And then let's have a conditional. If we have some blogs, we'll just present them like we do on the home page. But if we don't have any, we'll add a button that takes us to a create new blog page. So the conditional will look something like this. If we have the blogs content array and the blogs content array's length is over 0, we'll just present what we did on our home page as well. So we do this mapping and return blog cards. Copy that, paste that in here. But now if we don't have any blogs, we'll want to indicate that you don't have any blogs, go create one. So over here, let's add a div with some styling, nice little big font with 100%, and put a paragraph saying no blogs yet, but underneath add a button from Web3 UI Kit, which we'll have to import, and we'll have to create this click handler that will navigate us to the new story page. So let's go ahead and do that. Import button like so. So now we have button from Web3 UI Kit, but then we'll also want to import navigate from React Router so we can navigate. And then we can go ahead and create that click handler function over here, which is going to be super simple. We just navigate to the new story page, which we haven't created yet, but it should work beautifully. So if we save this, seems like there's an error somewhere down the code. Yeah, we never close the squiggly bracket, close that over there. And now save this, go check out our app. And we get an error saying navigate is not defined. So we have to destructure navigate from use navigate. Go back to your repository where you have your state variables. Make sure you call navigate from use navigate because we use that in our function call over here. Save that, go back to your page and look at that. Your blogs, we have our J's first blog because we define it. But now let's go back to our repository and not have this blog in our blogs array. We should get a different view. So set blogs, we can comment this out for now, like so, save that. If we go back to our page, we get this beautiful no blogs yet view, and we can go ahead and create one. And that takes us to the new story route, which we'll create next. You already know the drill. Jump back into VS Code and go find the new story.js file in pages.js over here. Let's close down some of these files. And here we see a pretty much empty functional component once again. Now, all we really have to have in this component is a form where you can input the title of your blog post and then the main body text of your blog post, and then publish it. And then we'll actually have Web3 execution functionality to actually mint that blog post as an NFT that can then be displayed in the Your Blogs page and the overall All Blogs page. But now, first off, let's start by introducing a few state variables. So the title and text, which will constantly be changing when we change our form. So we have a title and a text state variable, and both initialized to empty strings. And for functionality, just typing a title and a text, we don't actually need to define anything. So we can straight away jump into defining the HTML. So first of all, we'll have a form, as I said, like so. Give it a class name of write form. We won't have an onSubmit event yet because we haven't defined it, but don't worry, we'll create one soon. Now in this form, we'll have two divs, both with a class name of write form group, and one will take in the title and one will take in the actual blog content. And after these divs, we'll have a button saying publish with a class name of write submit, and this will allow us to eventually mint our blog. But for now, let's focus on these two divs. So we'll have an input. The first input will be as follows: write input is a placeholder title, type text, and the value in itself will be the title state variable. And on change, we'll constantly set the title to what the target value is. And then the same thing we'll do for our main content, but rather than having an input, we'll have a text area where the placeholder is tell your story. How fitting is that? And then on change, we of course set the text state variable, and that is the value in the text area. So with this basic HTML, you should have a pretty nice setup already. So if we go save this and check out our app, look at how cool this looks. We have a nice publish button, tell your story, where you can type whatever you like, put a title, hi there, and everything is looking beautiful. We can go to our own blogs, which we didn't have any. We can go to our homepage where we have that one blog already. And if we press this, we can go to this blog. Now, if we go here, create a new blog, we come back to this page where we can create a new story and publish our NFT. So essentially that is our front end complete. And now we can move on to the Web3 bits where we actually type something out over here and then publish that as an NFT, and then go ahead and use the Web3 API to read all the NFTs we've published into these blog cards where we can actually go ahead and read the blog. So now let's just focus on the Web3 bits and we'll be ready in no time because Moralis makes it so powerful. Jump back into the new story page. And let's focus first on executing a function to mint an NFT. Now returning into our VS Code, we can work here in our new story.js file. And to be able to mint an NFT, we first have to have a token URI that consists of the metadata for that token. And to do that, we need to store a JSON file on IPFS. But luckily, Moralis comes in clutch and does this easily for us. So let's first of all import some functionality from React Moralis, like so. So we use Moralis file, which will help us upload our NFTs data into IPFS. And then we have use Web3 execute function to actually executing functions on our smart contract. And then of course, just basic use Moralis for some basic functionality like getting the account and converting our numbers into the right decimal places for paying for our NFT mint. All right, so now let's destructure what we need from these hooks. Under our state variables, let's go ahead and add save file from use Moralis file, Moralis and account from use Moralis, and then we'll call contract processor our Web3 execution hook. And now for creating our function, let's first create a function that just uploads a JSON of our title and our text into IPFS. All right, so creating that function called upload file and a synchronous function. First, let's go ahead and get our text and turn it into an array. So just using .split turns it into array, which will be easier to store in our JSON format. And then we can make a metadata object with our title, and our new text array variables. So this is eventually the object we're going to want to save as JSON. And you remember, this is the format we usually have our external URL in. So you can start seeing those connections already. And now we can go ahead and do a try to await and save our file. We'll just give it a default name, myblog.json, and store it in base64 format and stringifying our metadata object over here, save IPFS. So this is a Moralis functionality that just takes in the file name you want to save, then the data that you want to save, we convert it into base64, and then an object identifying, do we want to save into IPFS, and the format of the data we are saving. Now, after our file save has completed, we can alert our result.ipfs, which will give us the address to the file that we have just saved onto IPFS. And if it doesn't work, we can catch over here and alert what the error message was. And now with this setup, the only thing we have to do is on submit of our form, we have to run this upload file function. So over here on submit, we can run upload file like so, save that, and now everything should be fine, except for the fact that we have to prevent the default action when we submit our form. So over here, we'll put an event and then prevent the default action so we can actually go through our upload file functionality. And now if we save, everything should be working perfectly. Head back to our app. All right, so here we can try and post IPFS test hello world and try and publish this. We get our alert. This is the address that our file was saved to. And when we look at it, we get our title, IPFS test, and the text hello world. So how cool is that? We know that our Moralis IPFS save functionality is working. Now this is the external URL. We actually have to make another save to IPFS with the token URL, having an image, a description, and the external URL stored in. So we have to make another function, heading back to Visual Studio Code. And here, rather than alerting our IPFS URL, let's use it as a parameter for another function called upload NFT metadata, and create that function below over here. It's going to be this exact same function, but with just a different metadata parameter over here like so. So upload NFT metadata, it takes the external URL as parameters, then it creates an object for itself where it has the image. We have this preset image that we used already in the hard-coded example. And then as the description, we use the title we type for our blog. And then the external URL we get from over here, already uploaded to IPFS. Then we go through the exact same process, saving the file. We call it metadata.json, convert it to base64. And then we return this result.nft. So then back in our upload file function, we can use that beneath here by just storing whatever this function returns. So const nft result equals this. And now we can alert nft result dot IPFS brackets. And I also realized, of course, this is a synchronous function, so we have to wait for this function to run through. So save that. And now we can go check out how this works. Back here, typing out a new blog. Let's do blog 1 token URI test. And publish this. Seems like we type broken URI, but that should work. We got our URI, copy that, go check it out, and look at this. We get a token URI with the image and the description and the external URL. And if we search for this external URL, we actually get our blog 1 text broken URI test. So now everything is working perfectly, and we can convert this publish button to not just alert to us where on decentralized storage on IPFS we've saved our token, but we can actually mint an NFT on our smart contract with the token URI we just created using Moralis and IPFS. How cool does that sound? And then we can actually start using Web3 API to query for it and then display them here on our homepage. But now let's create that execute functionality, go to Visual Studio Code, and we're going to start using this contract processor. And we'll use it inside a mint function we can create over here. So a mint function that takes in an account and the URI we've just created already. And to get started with this function, let's define some options our contract processor can use to identify which smart contract it needs to talk to and which function inside that smart contract it needs to talk to. So let options. And within this, we'll have 5 keys. We'll have a contract address, the function name, the application binary interface for that function, the parameters this function takes, and the message value that needs to be sent alongside this function call. Let's open Mumbai Testnet Polygon Scan and get these details for us. All right, so back at this page where we had our verified smart contract we created earlier on the tutorial. And first of all, you can get the contract address from over here. You should have already had it, but latest you'll get it from there. Add it to your contract address. Now, for the ABI, because you have a verified contract, you can scroll down to almost the bottom of the page and you'll have the section called Contract ABI. And here you should find a function called SafeMint. And so a quick control find should find it for you very nicely, and you can go ahead and copy that out from over here, this object, head back to your IDE and paste it inside your ABI over here, like so. Seems like we skipped this function name, but that is the SafeMint function over here, and paste that into your function name. Now for the parameters, we have two parameters. We have the to address and the URI, and because our mint function itself takes two parameters, we'll use those even as our parameters for our function call. So our to will be the account we're logged in as currently, and the URI will be the URI we call in our mint function, which we will get from our IPFS save. Now for the message value, you remember that we set that you have to spend 1 matic to be able to post a blog. So we can use the Moralis helper function over here called Moralis units, and using ETH, that just uses the network's native currency and uses 1 matic, so that will convert us to the correct decimals and have those 18 zeros for the message value. And now with all the options set, we can go on ahead and call our contract processor like so. So we just wait for our contract processor to fetch the parameters using the options we just set over here, and on success we'll get an alert saying successful mint. We'll set our text back to an empty string and our title to an empty string so we can make a new blog post if we want. But if there's any sort of error, like you don't have enough funds or any other error, we'll alert the error to the user. And now that is it. All we have to do is call this mint function we created rather than alerting our IPFS URL. So over here, we await for our mint to happen for the account that's currently logged in, and as the token URI, we'll set the NFT results IPFS that we've just saved in these upload functions. And now let's save this and go ahead and try this out. Now what we can do is give it a title. Blog posts as NFTs, and then we can tell your story. And what I'll do here, I'll just put a slightly longer lorem ipsum sample text for us to mint, and let's try and publish this as an NFT on our smart contract, see if it works. After pressing publish, we do get a MetaMask notification to send 1 matic to our smart contract address with a SafeMint function call. Let's confirm this transaction, and automatically we had a successful mint. Okay, if we go check out our MetaMask, we can see that our SafeMint actually worked out, and because we're on the same account as the owner of this smart contract, we didn't lose any matic. But we can't see the NFT here yet, because this is just a hard-coded blog post that we have. We haven't used the Web3 API, but we could go to our contract address over here, and we can go and read our contract, because now we should have 2 tokens. Go ahead and check out our token ID 1, which is the NFT blog we just minted from our website. Query this, and look at this. We have a string, we have this NFT minted. Go check that out, and looky here, it is a valid IPFS file saved as a JSON. We take this external URL, which should have our title and our blog post itself. Copy that, paste it in here, and we have this whole lorem ipsum text and our blog post as NFTs title. So everything working great so far. We can actually go ahead and mint NFTs from our app through our smart contract. Now last bit is just to make them presented over here, and then on our Your Blogs page, we'll want only the blogs that we ourselves have minted to show up. So this is starting to look very good. Let's go ahead and implement the Web3 API on these 2 pages. Jumping back here into Visual Studio Code, and I find myself in the home auth.js file. So this is the home page where we should see all the blogs that are minted on our smart contract. And essentially what we're looking to get is this array of objects with the external URLs and the owner of the minter of the NFTs. And how we do this is, like I've said already, we use the Web3 API from React Moralis. Let's also call it over here in our component so we can easily use it. Const Web3 API equals use Moralis Web3 API hook. And now we can get our hands dirty and actually use it. So we'll want to create another function that we call in a use effect later to fetch our NFTs using our Moralis Web3 API. So we'll create a function called fetch all NFTs. And first, for the Web3 API, we have to provide a few options. So in our case, because we know that our smart contract is stored on the Mumbai chain, We define the chain, Mumbai, and then we know our address of our smart contract because we've been working on it. So this is the smart contract you defined earlier when we deployed that smart contract on Hardhat. And now we can actually go ahead and call our Web3 API and wait for a result from it. So go ahead and create a constant called Polygon NFTs, where we await our Web3 API using token parameter, and within the token parameter, the get NFT owners, using these options that we defined earlier over here. Now this will give us an array with all the owners of NFTs on this smart contract and the details for these NFTs as well. Right, and now if we do get this Polygon NFTs array, we can map through it and actually get an array with all these external URLs and the owners of the NFTs. So let's see how we do this. So let's create this variable called token URI, which maps through all the Polygon NFTs if we have them. And then in the Polygon NFTs array, if the object has a result key, that will hold all the details for that NFT, including the stringified metadata, which will have, in our case, importantly, the external URL of the NFT. And then this results object also includes the owner of parameter, which has the owner wallet address for the NFT. So we just destruct those from each of our elements in our array. And then if we do have this metadata parameter, we can parse the JSON and fetch that external URL so we can paste it into this format over here. And then later on use Axios to fetch the actual blog contents from the external URL. And what we return is this object called external URL and owner of, and we store it in this token URI array, which we can actually at the end over here set as our blogs. So set blogs token URI. And now essentially when we run all these fetch all NFTs functions, we eventually set our blog state variable to have all the NFTs in our smart contract rather than this hard-coded blog, and we should be able to present on our front end all the NFT blogs from our smart contract. How cool does that sound? So for now, we can go ahead and delete this hard-coded NFT like so. And now we only need to create a use effect hook, which calls this fetch all NFTs when we don't have a blog's state variable. So we'll go ahead down where we have this use effect already. Let's create another one. So this is just a hook to call our fetch all NFTs function when we come to this page. Actually here, we could also have the blogs and blogs content. So now if we've done everything right, we should be using our Moralis Web3 API to fetch our smart contracts NFTs, and because we've already coded the UI so effectively, we should actually just get all our smart contracts NFT blogs on our front page. Let's go ahead and save this page and check it out. And would you look at that, now that I opened our dApp, look at this, we have the two NFTs we've minted on the smart contract. One, Jay's first blog, we minted straight from our smart contract on Polygon Scan, and then this one that we just posted using the publish functionality on our dApp itself. And the greatest bit is it shows us which wallets have created these NFTs, so have put the one Matic in to be able to post these blogs, and we can press them and it takes us to the blog page. We get the title and we get this nice little body of text for that NFT. We can try the other one as well. It all works seamlessly because we've been doing so far. So if you've been following the tutorial, you've done great so far. Last thing now is just showing your own blogs on this page with a Web3 API call that filters all the NFTs based on a provided wallet, which we can get from the logged in user. This will be super easy as the implementation is basically the same as on the home page. So jump back into Visual Studio Code and find the myblogs.js file. Now, again, we have to import Moralis Web3 API, but we'll also import Moralis so we can get the account that is authenticated and the authenticated and initialized state of Moralis to actually get their wallet address. Now at the top here, let's first again get Web3 API so we can use the Web3 API hook. And then from Moralis, destructure the is initialized state, the is authenticated state, and the currently logged in account. So this will be their wallet address, which we'll use as a parameter for our Web3 API call. And then we can do the same fetch NFTs function as we had on our home.auth page. So get fetch all NFTs, copy this, go back to your My Blogs page and paste it in. But now for the options, we have to provide another parameter, which is address, and this will be the account we brought in from Moralis. And now your token address parameter will be called token underscore address, and not a semicolon over here, just a comma. Now one last thing, to get the Polygon NFTs, we're not going to use the token parameter because we're going to use the account parameter. So you could get these away from here and paste in the account parameter and get NFTs for contracts. So this will get this account's NFTs for this smart contract. And then for the use effect to call this fetch all of NFTs, let's go down where we already have one use effect, and over here paste this use effect, which is triggered on authentication and initialization of Moralis. Again, for fetching the blog content, we can add these triggers over here. And now, you might not believe it, but that is basically the full build. So if we save this and head back to our app, back on the homepage, nothing seems to be broken, but the moment of truth, going to your blog's page, we have one blog that we have posted as an NFT to this Medium clone. It's posted by 0x4d. We can check the account that's currently connected, 0x4d. So this is our NFT. We can even jump to the NFT itself over here. And now if we wanted to check this other NFT, so Jay's first blog, 0x5d, let's log into that account. So go ahead and log out. And now let's change our account. Go MetaMask, account 2 over here, which is 0x5d. Connect this wallet, MetaMask, account 2, connect, sign. It takes us to the home page. And if we go to your blog's page, you get Jay's first blog over here. So this is the only blog that we have posted onto this Medium clone, and it takes us to that blog. So how cool is that? You've created a Web3 Medium clone where you can post your own blogs as NFTs. They're saved onto a smart contract where anyone in the world can see who has paid one Matic to post their blog onto this Medium Web3 clone. And then you can also view the own blogs you have spent the time creating and posted onto the smart contract. I really hope you enjoyed this tutorial, gained a lot of value from it, and it motivates you to build with Moralis and in the Web3 space. I'll see you in the next one.